Okay, so let's take a look at the definitions for these. A compound. The definition of a compound is that it's a substance made from atoms of two or more elements that are chemically bonded together. And some of your examples are sucrose or water, or here we have carbon dioxide. Okay. So CO2 or H2O. Or we could have C6H12O6. That is a compound. And these are all pure substances. An element is a pure substance made of only one kind of atom. So anything off the periodic table that we talked about, sodium, potassium, carbon. But also there are these 7 elements, special elements on the periodic table that are diatomic. They occur in twos when they're by themselves. They occur in twos. So oxygen's not just one oxygen atom floating around in the atmosphere. Oxygen is actually 2 atoms bonded together. And this is called diatomic. And when we get to that part of the periodic table, I will tell you which all of those are, and you'll have to memorize those and know where they are. Okay, so here we have hydrogen, H2, and then here could be sodium, Na. Any questions over pure substances? So next we're going to take a look at mixtures. So a mixture, there are 2 types of mixture. We have a homogeneous mixture. The prefix homo means the same. So this is a mixture that has a uniform composition. So if we all had to wear uniforms to school, we would all look the same because we would all be wearing the same white shirt with black pants or blue pants or whatever. So we would be a uniform composition. We would all look the same. An example is a salt water mixture. So if you were to take a glass of salt water and look at it, you cannot see those different parts. You can't just see the salt. You can't just see the water. It's all mixed together. At the microscopic level, or at the particle level, this is how it could look. You can see that this is a uniform composition right here. And then, that has a nice little pattern to it, but here it can also look like this. Okay, so this would be a solid, say, brass, and this could be a liquid of 2 different elements. And then we have a heterogeneous mixture, hetero meaning different, non-uniform composition. So we don't have to wear uniforms here. So we all get to wear whatever we want to wear, as long as you're in dress code. And so we do have, we all look different. So a mixture of clay and water, or a mixture of, like here, we see oil and water. If I look down at the particle level, here we can see that we have this nice division between each layer. Okay? So if you can see that nice like horizontal division at the particulate level, then it's probably going to be a heterogeneous mixture. So I need you to be able to look at something at the macroscopic level, say salt water or sugar water, and then to be able to look at it at the particulate level. Any questions on mixtures? Everybody good? Yes? Okay. So let's put this into a flow chart. So what is going to be at the very top of my flow chart? Matter? Matter. All matter can be put into these two categories. All right? You're going to take and you're going to look at your matter. And look at your matter and say the following. Can it easily be separated? So if it can be easily separated, then what are we going to classify it as? Mixture. Now, you look at your mixture and you look at it and you say, is there a uniform composition? So if there is a uniform composition, it looks the same throughout. What type of mixture is it? Homogeneous. Another word for homogeneous, and you're going to hear me say it all the time, solution. That is synonymous. All right? So homogeneous, if there's a uniform composition. So an example of a homogeneous mixture, salt water. I would probably say the air we breathe is a homogeneous mixture. Okay. If there is not a uniform composition, then it is heterogeneous. Okay, so if it's not uniform composition, it is heterogeneous, and an example of a heterogeneous mixture is oil and water, or everybody likes to use this one, trail mix. Okay? Now, let's go back to matter and say it cannot be easily separated. So if it cannot be easily separated, what are we going to classify that as? Compound and element both go into this this section. So if it's an element or a compound, it is a pure substance. Okay? A pure substance. And a pure substance can be broken down into two sections. If it is made of one or more types of matter. So if it's made of one or more types of matter, then it is called a compound. And some of our examples have been carbon dioxide, water, sugar, and if it is only made of one single type of matter, it is an element. And we have carbon as an example, sodium, oxygen, and iodine. And remember, I put those two there because those are called diatomic. They occur in twos when they're by themselves. So that is the matter flow chart, and this is what you're going to see throughout the year. Are there any questions? Okay, you're going to go, not to the bins, you're going to go to the back at the lab stations, and there are 12 plates and beads back here. And you're going to take the beads, and what I want you to do is within your groups of 2 or 3, because there's 12 tables, you need to model for me an element, a compound, and a mixture. And when you do the mixture for me, do a heterogeneous mixture and a homogeneous mixture for me. And when you think you've got it, I'm going to come around and check your answers. And then we're going to go on. Are there any questions as to what you're doing? All right, get back there and go. Okay, so now what I want to do is the following. I want to take a look at a element, and at the particulate level, I want to look at this element going from a solid to a liquid to a gas. All right, yesterday we talked about the 3 phases, solid, liquid, and gas. And so say I have I just want to take, let's go with nitrogen. So I am going to take nitrogen here, and here is nitrogen in a solid form. And what happens is, as I increase the temperature, what's going to happen to the particles? They're going to start spreading apart, being less organized. What happens to the forces holding together the solid? So there are forces holding this nitrogen to this nitrogen to this nitrogen to this nitrogen. And so as a solid, those forces are holding it together. But as I heat it up, what's going to happen to those forces? They're not vaporizing. They're going to melt, but not dissipate. Okay, so if I have strong forces holding me together, and as I go to a solid, they're going to start to weaken, or a liquid, well, they're going to weaken. So my forces weaken. And they let us start to, these particles spread apart. And then as we get to a gas, we're no longer going to have forces holding those particles together. Okay? If we were to go back the other way, then I'm going to take those forces and we're going to start those particles are going to get closer together and the forces are going to start strengthening. Any questions over that? So you need to know that forces are holding these particles together, and they either weaken or they strengthen depending on which way we're increasing or decreasing the temperature. Now what if I were to take a compound? So this time I'm going to take water and then you need to be able to show water going from its solid state to its liquid state to its gaseous state. Okay, so you got to be able to show each particle and what each one of those particles represent. Any questions over that? So what we're going to end with today is we're going to take a look at some pictures, and I'm going to just call on desk numbers, and we are going to classify some particles as either solid, liquid, gas, and then as element, compound, or mixture of elements, compounds, or both. Okay, so here we have A. A has, those look like dark maroon balls or something. So is it solid, liquid, or gas? Gas. And why is it a gas, not a liquid? They're spread apart. And is it element, compound, or mixture?
Element. It's all the same.
It is a element because they are all the same, yes. What about B? It's a liquid. What makes it a liquid and not a solid?
Not completely together.
Not completely together, not tight, not organized. Less organized, good. Now, we have this here. So what is that? A
Homogeneous.
compound.
Oh, no, it's a whole. It's the same.
I would say, okay, wait. When we talk about compounds, we're not going to talk about heterogeneous or homogeneous compounds. When we talk about heterogeneous or homogeneous, it's always within a mixture, okay? So we have a compound. We have a red ball here, which is a element, and then we have a red ball out here, which is another element. So this is a mixture of two elements and a compound. What about C? What can we say about C? It's a solid. And we have gray ball, blue ball, gray ball, blue ball. So what would we call this? A compound. What about D? It's a gas. We have a blue ball and then we have a red ball. So it would be a mixture of elements. What about E? What can we say about E? It's a solid. And we have orange balls on either side of some black ones, so compound. What about F? It's a liquid. And we can say we have it's a mixture of elements and compounds. So it has both in there. And how would you classify that? Would you classify that as heterogeneous or homogeneous? Do you see a nice line of demarcation where you can put a line right through them? No. So we would call this homogeneous. Okay? What about G? It's a gas, and it's composed of compounds. And we could probably put a line right through there. So we could probably say it is hetero. And what about H? Last one. It is a liquid. And Doy says element, and Doy would be right. What type of element is that? A diatomic. Okay, so you need to be able to look at those at the particle level and determine solid, liquid, gas, and then versus element, compound, and mixtures of element or compound, and whether it's heterogeneous or homogeneous. So what B, would you say B is heterogeneous or homogeneous? It would be homogeneous. Okay, I can't draw a nice line in there. Either if I wanted to draw it as a vertical or horizontal, I couldn't draw a nice line in there. Okay. So tomorrow we'll pick up here as our bell work, and then we will get into looking at some more particles. Are there any questions?